So the components. They have three main components, and that's the same for every Internet of Things project. If you can just slow down a little bit. It will be quick, I promise. And if you're not interested, feel free to just come back in 30 minutes and I'll answer the questions, don't worry. I'm not upset. So anyway, continue. These are the three components. You have the things itself, we have the connectivity and the applications. We're going to talk about all the three components right now. So what are the things? They are the sensors. We talked about already on the week 11, so that's why it's kind of repetition. And what are those? Those are the motion sensors, badge readers. We have one of those on the door there for the smart lock. The small device like a black square. The GPS trackers and engine controllers. Those are kind of sensors. This one is really popular for cars, and of course. And the actuators. Actuators are, instead of being the input, is the output. Similar to the whole idea of the Raspberry Pi that we had, like ways of receiving electricity and outputting electricity. Here, the things, we have the sensors and the actuators, the input and output. So now, actuator for the example of this room, on the smart lock there, is like open or closing the door, okay? And the connectivity, how does that connectivity work? That could be done by cable, on an internet cable, cellular like 3G, 4G, Wi-Fi, or some sort of other protocol. We're going to talk about a few of the protocols today. But yeah, just be aware that we might not use just standard HTTP or other stuff. Sometimes that connectivity is managed by some sort of IoT gateway. A lot of cloud solutions, they have services for that. We're going to talk about a few today. And there might be even some different types of connections like the M2M, M2S. So just be aware there is some sort of activity, connectivity related to those things that are connected, okay? And then last but not least, we have the applications that are built around that. So those applications, they usually have some sort of data storage because those sensors, they collect a lot of data and we tend to analyze that data. So that comes to the analytics and the visualization of the data itself. And since we have a lot of data, we can apply some machine learning techniques or AI associated with that data, okay? With that said, what is the IoT, okay? This means Internet of Things, and as per the description here, is a scenario where physical things communicate with each other or services over the internet. Okay, so the example of the smart lock, usually there is some sort of server there that collects data either if the door is open or closed, or there is a timer where it auto locks certain doors. I worked with a project that was pretty much that. So the backend was some sort of API service, and it had other connections to the things itself. In this case, the locks. In this example, the locks. And what's the definition of a thing? So a thing is an entity that exists physically, as opposed to something that exists in software. So basically, a hardware, some sort of hardware that's on the location itself. Okay. And this thing usually there has some sort of constraints that are different from smartphones and computers. And those constraints are, they don't necessarily need to operate on a reliable network. So in harsh environments, let's say in an oil platform, sometimes the internet doesn't work there, and the devices that are there, they should work across themselves without any reliable internet. On the example of the smart lock, if the internet is down, you should be able to open the door, right? So those devices, they usually have some sort of a security cryptography locally, or some sort of way to make things work. So the example of a smart lock, they might also work with a key, like a physical key. Okay? They also usually have low processing power and limited memory. So the software that you build on those kind of devices has to be optimized. That's why on the TensorFlow week we are talking about reducing the size of the models itself, because those reduced size models, they tend to work better on this kind of device since we don't have a lot of processing power. And another reason why they are low on processing power is to save battery. So that's another characteristic of those devices. They usually have really small batteries. So on the example of the smart lock, it's not convenient to recharge the battery every day like we do with our smartphones. So they are really optimized to run on low batteries. So they usually last for a really long time. Okay? And that thing can function as an actuator as well. So the actuator would be like the output on the real world. So in the case of a smart lock, opening or closing a door, that would be an actuator on the world. And the example of a robot, like the one of the Boston Dynamic, could be like moving an arm or moving a leg. Those are things, those kind of actuators, and that things can control. Okay? And with that said, how does it work? Typically, they have sensors that collects data, and they send that data either to other machines or to a service, okay, or certain systems. So people can analyze that data, find patterns, and build solutions on top of that. And that's what we see as the example here. You may perform some analytic data there to review the hidden patterns, make decisions there, and focus on important things. So on the example of the shopping mall that I talked about movement sensors, you can focus on the stores that they have high density and maybe do some sort of advertisement there, so people visit other stores and you can optimize the flow of the shopping mall. Okay? So here are a few applications of Internet of Things in our real world. We have autonomous vehicle. There we have a lot of sensors, and the sensors, they control parts of the car. Usually they are really specialized sensors, and they control really specialized parts of the car. We have smart grids. So basically those are things that are connected to each other, similar to a cluster. We have those server clusters that holds the cloud. We might have smart grids, like low powered machines that are connected together, and they want to achieve the same goal. So we can kind of come back to the autonomous vehicle again, because at the end of the day, they are built on top of smart grids. Every sensor, they have the goal of controlling the car, the example of Tesla, and they are managed by smart grids. We have applications on healthcare. So situations where we have devices for controlling the health data, provide some sort of a device, or even in surgery, those like smart scissors when you're doing a surgery, and they have sensors internally, and they kind of can help on the situations of a surgery. Those are also considered Internet of Things, and that's a great example of if you don't have reliable internet, that device shouldn't stop, because it can kill someone with that. That's not cool, so that's kind of the thing with Internet of Things. Agriculture. In some class, I gave that example. I'm not sure if I gave it here, but if you want to do like a smart garden or a smart way of taking care of plants, like you can build sensors and trigger them using an API that triggers from time to time, and you can water the plants. Those are some applications that you can do in real life. Another one that I did on my bachelor project, we had sensors below airplanes, and we are kind of taking pictures of areas. So those are those kind of mapping things and doing that automatically and send that to a server. Those are a few examples. We have other examples of manufacturing. So those robots, when you're coming back to example of car, when you're building a car, you have a lot of sensors on the robots that are assembling the car itself, or even other kinds of devices, so other electronics devices as well. Home automation. The example of a iRobot, that's the vacuum cleaner that cleans your house, that can be considered an Internet of Things. If your internet goes down, you still can use that. So that's another good example. And there are a lot of others. As you can see, this area is super open because any sort of interaction with the real world, you can kind of make some sort of software behind that. So this is really like open. And for the smart devices, here are a few examples of sensors and actuators. Okay, so you have infrared sensors, some switch buttons, touch sensors, temperature sensors, engine controllers, and the actuator itself. We have a light bulb. If you've ever seen one of those smart light bulbs, that's one example of actuator. Motors, monitors, buzzers, and engines, like the example of the Tesla car. Okay? And how do we build an architecture on top of that? Usually that follow these three columns here. No matter what kind of Internet of Thing you have, you probably have some sort of variation of those three columns. So here, in the first column, we have these sensors and actuators. Basically, the input and output, where you're going to collect the data or interact with the world some way, like the example of opening and closing doors, or I don't know, making an arm move, things like that. You have some sort of connection, not necessarily that we use the connection that we are used to, like the HTTP. On the example of smart locks, I use the MQTT, and there are others as well, like WebSockets. There are interactions that you can do by Bluetooth or other kind of stuff. So making this clear on your project is really important because you know the limitations of your hardware, so you kind of need to just follow those limitations. And you have the applications itself. It could be people analyzing that data, like a security guard with managing those sensors. I don't know if you guys played Among Us, but there is an area there that you actually can see people moving because of movement sensors. That actually happens in real life as well, in some environments. The clients of those sensors could be other devices. So on the example of the Tesla car, the sensors of movement on the front and the top and behind the car, they kind of help the car locate itself around and avoid accidents. Or it could be AI, so you could just collect that data and build an AI on top of that, okay? And as on the final project probably will do, just send some data to that AI and then get some sort of output. Okay, so now we're going to talk about a few visions, few ways that the vendors, they see the Internet of Things. First, we're going to talk about the IBM. So this is how IBM sees that. And you see a lot of names that are really specific for the cloud provider, because usually they not only sell this solution, but they try to sell a service as well, which is the example of this Watson Studio. But at the end of the day, they are following the same three columns that we are talking here. So in this vision, we have a device that has some sort of connection, which is this arrow here. They don't even specify the connection because they probably support several types of connection. And then you use their service of an IoT platform. With that service, you can connect it directly to some sort of NoSQL database. Here they are giving the suggestion of NoSQL because those devices, you might change over time, and the data might change it as well. Maybe you have a newer version of those devices. So, NoSQL database structure is used for that case when you don't actually want to strict the data that you have. And here you have the user connecting to a Watson Studio that has an analytic engine and some sort of cloud storage. So you can access that data, okay? Here is an example for medical things, Internet of Medical Things. Is a Microsoft vision of that. So they have, of course, like before, the services of Azure, which is the cloud provider of Microsoft. Here they have patients interacting with some sort of edge device. Could be a blood pressure kind of device, some sort of diabetes detector, or even one of those surgeon tools. And then those tools, they interact with the doctor in some way. And the way that's managed is by having the Azure IoT Hub. So you can have the control of device and have data of how those devices are performing. If there is some sort of device that has some sort of defect and you need to change, you can manage that remotely, okay? So that's their vision for this problem. And then last, this picture has a lot of information, but if you see the columns here, they kind of follow the same idea. Here, instead of having device, they have they call the edge itself. So you can have endpoints like Internet of Things that connect to SDK. Here they have a fan, the light bulb, and all that. And they have different protocols that connected those services. So here we have the MQTT that we are talking about. And we can connect that to all sorts of services on the AWS. Here they are suggesting using Lambda functions to receive the data and do some sort of processing. You can store that on the Snowball Edge or any other solution. And here on the cloud portion is where we do the analysis itself. So they have each one of those calls, those are kind of services that they have available. So AWS IoT Core, here we handle the messages itself, so we can do some processing if we want. Here on the AWS IoT device management, we can check in real time what kind of device, if they are available or not. So if they have any sort of defect, we can send a person there to fix the device. We have the Defender itself. Here they have some sort of machine learning models for detecting weird behavior. And they have those services available for you. And they have the analytics portion here. Here, usually people use the Amazon Kinesis. You might want to use something else like a Kafka cluster or any sort of a visualization tool. But that's what the goal of this column here. And once that's all set up, you can actually connect out that data to your enterprise applications as well. So here they give the example of the Amazon Redshift, S3, Amazon EMR, all AWS services, and even other Lambda functions as well. So you have the core apps here. So all these three, they kind of follow this structure here. You have some sort of a device that collects some sort of data. That device has some restrictions regarding the connection, and you send that to your applications or to people to analyze that data. So that's what we kind of see here on all these three charts. And this AWS one is really cloudy here, like they have a lot of services, but you can make this simple, maybe have a Lambda function, message broker, and then you reach your application. The company that I work, we did something simple like that, and we could manage the smart locks by doing that. Okay? So, as a summary, Internet of Things is a huge topic. This is just a scheme of the surface of the course. We have a course that's Comp 216 that they talk only about these kind of things. So we will learn some sort of network protocol. I don't know how valid this is because I heard some people are on the last period, but if you're not on the last period and you're interested in this kind of stuff, here's a suggestion. And as we saw on those diagrams, we have each vendor, they have their own vision on how IT solutions should look like. And even if every company, if you're building something that has some sort of legacy code, maybe you have something slightly different there. So as a suggestion, if you work on this topic or you're interested in this topic, just adapt to the company that you're working with. Okay? So yeah, like I said, this was quite a quick lecture. Do you guys have any questions regarding this topic?